Hello everyone, this is Dr. Zach again. For your lesson preview, I would like you to use Euler's method. And with Euler's method, please take 4 steps in order to estimate y at 3, given that ye is equal to e. You may use your calculator. Please remember to build a table of values as you write your question out. For question B, I'm asking you to use Simpson's method. There's a blast from the past where n is equal to 6. Go ahead, use that to estimate the area under the curve from x equals 1 to x equals e. Get started. When you were working on question B, did you remember that you should first write your integral? The integral is the most important part of the function. So we want the antiderivative, or the integral from 1 to e of natural log of x dx. That is where you're going to begin. You're going to let your f of x equal the natural log of x, and then you're ready to use that Simpson's method. Did you recall that the integral, because of Simpson's method, is going to be approximately equal to your delta x, which would be e minus 1 divided by 6 multiplied by 1/3, and then you're going to follow through starting with 1 times f at 1 plus what's your next value? Should be 4 times your f at, and then you're going to add a little bit more to the 1. Then you're going to have plus 2 f at your next value. So that was going to be your 1 plus delta x and 1 plus 2 delta x. Then you're going to continue following this pattern using 1, 4, 2, 4. Then we will have 2 again with f evaluated at our next value. And of course, our last one is 4 for our pattern plus the last term, which will be f at e. So figure out those numbers and then move forward. So let's once again talk about our product rule. If I have u times v and I say, hey, find the derivative of u times v with respect to x, you would say that that would be u times dv dx plus v times du dx, which is great. Now, if we go backwards and integrate both sides, we will have u times v is equal to the integral of u dv over dx. Now, I find the antiderivative with respect to x plus the integral of v du dx times dx. So the dx's, of course, cancel out, which is highly convenient. And now let's look at what we have one more time. We have u times v is equal to the integral of u dv plus the integral of v du. If I rearrange this just a little bit and I solve for u dv, I have the integral u dv is equal to u times v minus the integral of v du. All right, now this is actually the formula that we have for integration by parts, and we're going to be using that in order to solve problems that have 2 parts, a u substitution and a dv substitution. So let's start with example 1. We have dy over dx equals the natural log of x. Can you imagine that? We've been spending how much time solving calculus problems, and we still don't know the antiderivative of the natural log of x. Well, let's figure it out. We will have dy equals the natural log of x dx. Now, if I integrate both sides, I know that the antiderivative of dy is y, so that's nice. Equals. I'm back where I started. Look at that. That's funny. All right, so I still have the natural log of x dx. Now, we're going to pick out something to call u and something else to call dv. So when you pick out your u value, you want to find something that is easy to find the derivative. And the reason for that, remember our little formula that we came up with, is we're going to use the derivative of u within our formula. And we also need an antiderivative. So we want to find something that we can find the antiderivative of v. So let's see here. I only have 2 parts to this problem. Natural log of x, I don't know its antiderivative. That has to be equal to my u value, natural log of x, and dv equals dx. All right, so now, what is the derivative of the natural log of x? That's 1 over x dx. What's the antiderivative of v? That's going to be equal to x. If we follow our formula, u times v, so that's going to give me x natural log of x, minus the integral, you still have an integral here, of v times du. So that would be x times 1 over x dx. But wait, x divided by x is 1. So when I finish this problem off, I have x natural log of x minus antiderivative of 1 is x, and then we put in our plus c. Now, I acknowledge that over here we have integrated, and we should have written a plus c, but we wait until the end of the problem to put in our plus c. Okay, what else do we know? We know that y at e is equal to e, and so if we know that, e is equal to e, natural log of e, minus e plus c. This is silly. Natural log of e is 1, e minus e is 0, so c must be equal to e, and our final function, we have y equals x, natural log of x minus x plus e. And when we find y at 3, we're going to substitute 3 in. And remember, for your AP exam, you do not need to simplify. You can leave it with numbers within your problem. Let's take a look at example 2. We have x multiplied by the sine of x. Now, you cannot use algebra to simplify the problem. Use substitution, long division, trig identities. So let's try our new method. Remember, we want to pick out a u value. The u value is what we will find a derivative of, and our dv. So the v is the part of the problem we want to integrate. It is possible that you will choose the wrong components. So let's start with, can I find the derivative of the sine of x? And yes, I can. Can I find the antiderivative of x? Yes, I can. So let's try that. In which case, we get du is going to be equal to the cosine of x, don't forget your dx, and v is equal to the antiderivative of x, which is x squared over 2. As you'll recall, we're going to use the formula u times v. So to get an equivalent expression, we will have x squared over 2 times the sine of x minus the integral of our v du, which is going to be x squared over 2 times the cosine of x dx. Okay, now let's look at what we have. The integral that we ended up with is actually worse than where we started. That's a clue. You went in the wrong direction. So we're trying to simplify the problem. When we see a problem that has x as one of the components, we're going to let u equal the x value, because the derivative of u is going to be dx, and that will be very helpful if we're trying to simplify our problem. So change the problem up. We're going to let u equal x, dv equal the sine of x dx. Then we'll find du. du is equal to 1 dx, and v is going to be equal to the antiderivative of the sine, which is your cosine with a negative, and x. Now, we will follow through with our formula. Remember, these are equivalent expressions. The first one we had just wasn't very useful. We have u times v, so that's negative x cosine x, minus the integral of v du, so that's u, v du, and we will have a negative, which is a positive, cosine x dx. All right, now when we look at our new integral, you can see that the second part is very easy for us to integrate, so we are on the right track. So we'll have plus cosine of x, plus sine of x, and then remember to add your plus c. Looking at example 3, so let's start with the same idea. I can easily find the derivative of t squared. So I'm going to let u equal t squared, and we're going to let dv equal e to the 3t. Okay, put my dt with my dv. du is going to be 2t dt, and v, so it's an antiderivative, so that's 1/3 e to the 3t. Okay, follow through, u times v minus v du. We're going to let u, our expression is going to be equivalent to 1/3 t squared e to the 3t minus the, put your 2/3 out front, get that out of my way, the integral of t e to the 3t dt. Now I'm looking at t e to the 3t. It looks to me like I'm going to have to do integration by parts a second time. Don't worry, we can handle this. U is equal to t, and dv is equal to e to the 3t dt. So once you've decided that du in the first part is e to the 3t, continue with that process, even if you have to do a couple of steps or a couple of integration by parts. Find our antiderivative. We have 1/3 e to the 3t again, and now we're ready to find an equivalent expression. So we keep our first term, 1/3 t squared e to the 3t minus 2/3, and then we will rewrite this problem as 1/3 t e to the 3t when we multiply u times v minus our integral of v du, which will be 1/3 the integral e to the 3t dt. So we're not finished yet, but that's okay. We just have e to the 3t to deal with, and we'll end up with 1/3 t squared e to the 3t minus our 2/3, 1/3 t e to the 3t minus 1/9 e to the 3t, and don't forget to add your plus c. Now, if this is a multiple choice test, you're probably going to have a simplified answer, and that simplified answer will have e to the 3t factored out, and you'll probably see 1/9 factored out, and the remaining terms are going to be 3t squared minus 2t, and then we'll have a plus 2. So if you have a multiple choice test, be aware that factoring might have occurred. All right, just a point that you should be aware of, there are hypothetical shortcuts for finding antiderivatives for problems that have t squared, t to the 4th, and then some sort of sine or cosine e function in here. The shortcuts are great, but you are not going to be finding the antiderivative of these that often. So if you understand that you can use integration by parts once or twice within a problem, you will do just fine. All right, that's it for our notes today, and have a great time.